Okay, Bismillahirrahmanirrahim. We already discussed about the memory allocation like malloc. Here a little bit, what I'm doing is here the PTR and PD, 2 pointers, and n is the limit. Okay, and how many elements? He says, for example, 3 elements, and here we create three integers, so array of 3 integers basically, right? And that the base address of that, the first address of that will be in a PDR. Then I'm saying if PDR is equal null, that means malloc has failed, and you got to exit one. Then we say PDR is called PDR. Well, I'm putting the address of the PDR into PD. That's the first address, and then I run up to the n. What I do is I put in the PD. I'm going to PD plus plus because PD plus will jump to the next integer, and so on. And similarly, I will put it, again the PD into PD, the PDR, the base address, and I will start printing my value. So I'd say here asterisk PD, right? Okay. If I give it a go and it will work fine. This is what we had done in the previous program as well. So I say 3 elements, and I'm giving 12, 13, and 14, wherever. Oh, say error. We got 12, 13, 14, right? Okay. And second way of doing the same things, if you don't want this PD to be PD stuff, I will say PDR. I want to use the PDR, and I don't want to use asterisk. Then I have the array method, because this gives you an intuition that pointer and the arrays are same. So this time this is also acting as an array. So PDR is just like we declare the array. So we can say PDR and I using the offset. Only thing is we have to use here ampersand now. Ampersand, because PDR of I give the element, ampersand PDR of I will give the address of that element. So you can use the pointer method or array method because pointers and arrays are same as well. So if I give it a go, it should work fine. Okay, how many elements? I said 3 elements, and I got here like 12, 13, and 14, and I got it back. So this is my array method of accessing the pointers. So similarly, you can access the character arrays or whatever arrays, you can do that, right? One more thing is that after the end, when you finish it, you should release the memory as well. So you can say free this PDR, right? You should say free PDR. Give it a go, so that you release this pointer, the memory which is in a heap. So I say 2 elements like 1 and 1, 12, whatever. So we got it, and after the end it will free the PDR. Free, we show you create the memory, you should also deallocate it. So allocate it and deallocate it. So this will be the heap memory, and we have the other guys also for the malloc, which is like calloc and the realloc. And one thing to note down is this memory is being created in a heap, but if you're a global variable, that's created on a static area, and if you're local variables like these are created on a stack. So we have 3 memory locations for variables. These on a stack. If you have some global variable like here, I'm gonna int a. This is going to be in a this is a global variable. This is gonna be in a static area, okay, or in a program area, wherein this lines of code are these lines of code will be in some memory. That's again the static area. That this will be there as well. If you say here like static int a, this is also going to be in a global area or static area or in a program area, right? And these variables are going to be in a free area, sorry, in a local this is a local variable. This will be in a stack. And if you say this PDR, which is being created dynamically, this will be in a heap, the free memory, right? Okay, now we go to the calloc and realloc. Okay, now this is the example of calloc. Okay, what we are doing is basically we are creating a structure here, okay, and type def into the st, another couple of pointers here, and I say n and I for limit and loop variable, how many students in the n. Then I create typecast into the student asterisk, st the structure asterisk, and then the n comma. This is how we use the calloc. If it's in malloc, we're going to use n into size of st, but in calloc is n comma size of st, right? Okay. If PTR equals to null, print of calloc failed, exit 1. Okay, simple. So then put in the PTR into PD. Now what happens is basically we have the array of structures now. So that's why we first put in the first PD points now to the first structure. Okay, that's enter name. Now we put in the ptr arrow name and roll number ampersand ptr arrow roll number, right? Put in the roll number there, and now pd plus plus, pd will put point to the second structure, because we may have, if we have n is equal to 3, we may have 3 array of structures. So the array itself, the first box of array will have one structure, second array will second structure, third array will third structure, and so on. Okay, then I'm again putting into the ptr the base arrow, the first address, the first structure, then running the loop and putting them back, right? And free the pointer at the end. So I say, for example, 2 students, I say Junaid, and roll number 1, I say Abid 2, and we got it back, right? Now this is how the clock works. If I use here the, instead of clock, I'm saying here malloc. Okay, will it have some effect? Okay, that's the problem. Okay, that's gonna be having problems. So malloc is not used for variable sized blocks. It's used for continuous blocks of, say, for an array, but not variable sized blocks, right? So we have to use a clock for this. So that's it. We go for a next video, realloc and other functions in the next video.